to start today, I'm following up with some work that you were just seeing on our wall map work earlier in the week, where you're reminded about factoring quadratics, something which you theoretically saw back in Algebra 1, and when you scrape the dust off of that old skill and get you good at it again. So hopefully you got a reminder on that. Go ahead and use what you saw on wall map. Factor this problem, please, and then we'll talk our way through it to make sure you got the whole idea down. All right, so what you would have seen on our wall map problems where it included the instructions on how to factor these is that factoring, first of all, remember, always introduces parentheses, and that when factoring a quadratic like this, we're actually going to end up with two sets of parentheses. Each of those sets of parentheses starts with an x, and then it's going to be plus or minus some number in each one of them. Now, my suggestion in terms of strategies on these is focus first on the signs, so you know what to expect in terms of positives and negatives. You notice in this case, we are multiplying to a positive. What's that tell you about the signs? It tells you, it tells you they're both the same at least. It doesn't tell you they're both positive, it doesn't tell you they're both negative, but that at least tells us they're the same. We then look at what we're adding to. And since we're adding to a negative, that means they both then must be negative. And so I already know it's going to be x minus and x minus. From there, our strategy is that we say what two numbers add to the middle number and multiply to the last number. And as you think it through, start by thinking about the multiply part. Don't start with, okay, what adds to negative 12? Because there's an infinite number of ways to do that. However, for getting 27, there's only a few ways to do that with integers. And so you might start like with 1 times 27. Okay, that wouldn't work because that adds to 28. Then 2, nope, that one doesn't go into 27. Then 3 times 9, that one works. And so then that tells me what my combination is. Now notice that as I did this is what you're doing in your head usually. I was doing it systematically. That's what I always suggest. Every now and then I'll see somebody do one of these and they'll be like, okay, well, what goes into it? Does 5? No. How about 2? Nope. 7? Nope. And they kind of bounce around like that. And it ends up meaning that they're often forgetting to check one that usually they think they've checked, but just haven't. And so being systematic about it really helps, especially if you're not seeing it right away. But in this case, it is 3 and 9. So our answer then is x minus 3 times x minus 9. Or x minus 9 times x minus 3. The order does not matter. As long as we have our signs correct on the numbers inside each, we're good. Now, the first question that normally comes up when we're taking a look at these two is for that first one, what are you adding to? 1. When you see plus x, remember that means the same thing as plus 1x. So in that case, you're adding to positive 1, multiplying to negative 110. All right, so when we actually go to factor it, of course, we know that the factored form will have two sets of parentheses, each one starting with x. Now look at the signs. In this case, we're multiplying to a negative. Anytime you multiply to a negative, that tells you that we have to have both a positive and a negative. It's the only way you multiply to a negative number. So one of them is x plus, the other one is x minus. The only question is what the two numbers are then. So to multiply to 110, if one's plus and one's minus, that means they need to be 1 apart from each other. Okay, well for 110 then that sounds like 11 and 10, right? The question is which one's positive? There, the 11 or the 10? 11. It's got to be the 11. Because I want to add to a positive 1, which means that when I add them, I have to have more positives than negatives. And so that's why the 11 then is the positive, and the 10 is the negative. And so that's our final answer. And again, you could also have written it as x minus 10 times x plus 11. That order does not matter. Just the signs with each number. All right, last problem. Again, we got to factor it, so we're going to end up with two parentheses, x plus something and x plus something in this case, because you'll notice that we're multiplying to a positive and then adding to a positive. So then, what two numbers multiply to 12 but add to 13? Well, yeah. This one sometimes is the one that trips people up because it is going to be 12 times 1. Why does it trip us up? Because in a lot of our algebra work, we've been taught to ignore the 1. You know, we say, well, what can I divide this number by? Well, we can divide it by 1. Okay, yes, but what else? We do a lot of that kind of thing. And like when we have an x written, we don't write the 1 in. We're often ignoring the 1, but this is one time you can't ignore the 1. It's a very valid possibility, and it will come up a decent number of times. The main focus of today's work, though, is going to be solving systems. And we're starting with one that is familiar, and then we'll be going into the less familiar. But I do like to start with what we already have down. Go ahead and write down and solve this system, please. All right, so in this case, we can go ahead and use substitution method. And since I know what y equals, I'm going to substitute that in for y. Now, when we do that, though, there's a little bit of a trick to this to make sure that we do it correctly and don't make one of those common mistakes. I'm going to do 4x minus, and then I'm going to put parentheses around whatever I plug in. So I'm going to go minus parentheses 3x minus 2. And then that equals 1. Now, why do I include the parentheses? Because if I leave them out, I'm subtracting the 3x and subtracting the 2 there. But if I leave them in there to show that, then notice that when I get rid of the parentheses, it's actually going to be 4x minus 3x plus 2. Because this minus that's out front here ends up distributing to both terms. It's like multiplying both by -1. So if you keep track of that in parentheses, then that very common error isn't going to trip you up. This is what all the work should end up looking like when you do it correctly. Then you should get an answer there of -1, -5. All right, so having done that problem, now we're going to go ahead and tackle this problem. So go ahead and write down this one. And our substitution method with this problem becomes a little bit more tricky, doesn't it? Because remember, in order to substitute, I have to know what one of the variables actually equals. And we don't have that right now. Now, the nice thing about this particular system is I could actually create that situation. That second equation there, I could actually subtract 3y from both sides. And if I do that, then I actually have x equals 7 minus 3y. Now I could use substitution, because now that I know what x is, I could plug that in for x in the other equation. It is a bit of an extra step, though. And one thing I want to point out about this isn't really a very sustainable method. Because what if that wasn't just an x? What if that was like a 9x? Then we'd have to be like dividing this whole side over here by 9 in order to get it. It's going to look really ugly, isn't it? And so I don't want to have to rely on this method in order to solve it. But we can use it at least in this case. If we do, this is what our work should look like. All right, so this method can work as you've seen here, but again, it's not very sustainable, because if that wasn't just a plain old x here, if there was a number in front of it, this would have gotten really ugly. So there is another method we can use. The other method that we can use for solving this is the elimination method. It's also called the addition method, or some people even do it as a subtraction method. The basic idea is that we can actually add and subtract equations together. For our purposes here, we're just going to worry about adding them, though, just so that we don't have to see how a few little nuances work along the way. And so I can go ahead and start by adding these two equations exactly as I see them. And so I add the 2x plus the x. That gives me 3x. And I add the negative 3y plus the 3y. Notice what that gives me. Negative 3 plus 3 is 0. The y variable was just eliminated when I added them together, hence why we call it elimination method. And then you notice the equal signs just carry down, and then I do the 5 plus the 7 to get the 12 here. In order to do this, how did I know to use this method instead of a different one? Well, first of all, neither of my original equations was either x equals or y equals. When it is, that tells me to use substitution. What tells me to use elimination is that the x's are lined up, the y's are lined up, the equal signs are lined up, and the numbers are lined up. Everything is aligned, and when that's the case, then you can go ahead and just add straight down. And yes, that's mathematically okay. And so when we do that, then we have 3x equals 12. Since one variable was eliminated, that means there's only one variable left we can solve for it. So we divide both sides by 3, we find that x equals 4. That's nice and short, right? That's certainly a lot less work than it was to get our first answer over here. The flip side, though, of elimination method is that the next step, while it's the same basic idea, it can sometimes seem like it's a little bit more work. But it's what we have to deal with because of the form that we are given these in. Because I'm still going to do the same thing of plugging in what x equals into one of the original equations. And it still does not matter which equation you plug it into. You can plug it into either of them for x, and if you're doing your work right, you'll get the same answer out. Now I went ahead and plugged it into the first one, just as an arbitrary choice. And so we plug the x equals 4 in for x, and then we're just solving that equation. And so we do all the algebra, and there we find that y equals 1. Notice, I did this same problem two different ways. I did it once by forcing substitution on it, and we got an answer of 4, 1. Did it once using elimination, we got an answer of 4, 1. Thank goodness it's the same, right? It's the beautiful thing about math, though, for a lot of us, is that once you know the rules of math, you can apply them in different ways, and it'll always work and always give you the same results. As long as you apply the rules right, they'll always work. All right, now with this example, you'll notice that the big difference between this problem and the last one is that if I start by just adding these straight down, nothing gets eliminated. And that's a problem. Because the whole concept behind this and the reason why it works is that we have to have them eliminate. So I'm not going to start by adding straight down yet. I have to do something first. I have to make it so that these will actually eliminate. And for that, I got a couple choices about how I could do it. For our first example here, I'm going to just choose arbitrarily to make the x's eliminate. Now, in order to do that, I can multiply one or even both of the equations by something. And so what could I multiply this x by so that when I added 2x that I would end up getting a 0 down here? Negative 2, absolutely. And so that's what I'm going to do. I'm going to multiply this entire top equation, both sides, by negative 2. Now, when we do that, let's see what that gives us. For that first equation, it becomes negative 2x minus 12y equals negative 58. So notice, every single term ends up getting multiplied by that negative 2. Now, I got to talk about a little shortcut that some people are going to be making, and some of you are even going to try doing this on tonight's homework. And I'm telling you now, don't take this shortcut or it will give you problems later. Some people will stop there and just go ahead and start adding. Because yes, the next technical step we're going to do is we're going to add those equations. However, some problems can occur with that. When you start doing that, you'll say, okay, well, I'm going to add this one and this one. Okay, great. Then I add this and this. Great. And then I'm going to add this and this. You notice that person just made a mistake. They went back to the other equation instead of going back to this number when doing that addition. So what I always suggest doing is write both equations again. Even if you didn't change that second one, write it down. And that way that error will not happen. And then finally, to be a little extra fancy with this and keep our notation technically correct, it's going to take some practice probably to get good at it, but draw that curly bracket next to it. So we're still showing that it's a system of equations. And yes, it takes some practice to draw a curly bracket correctly. Trust me, it took me a couple years. But you'll eventually get there. Now that we've written it like this, now we can actually add the equations together. Because you'll notice that when I do that, negative 2x plus 2x, they eliminate. They add to 0. And that's why I chose the negative 2. because I knew that would make it eliminate. And here you can see what it ends up being at the very end, what all of that math ends up working out to be. Now, I arbitrarily chose at the start of this one to make the x's eliminate. Sometimes it might actually be easier to make the y's eliminate. And that is also an option. So let's take a quick look at this problem. What if instead of making the x's eliminate, I wanted to make the y's go away? So that means I want to make this part add to 0. Do you see which equation I would multiply and by what?
The bottom one by 6.
Yeah, the bottom one by 6. Yeah, and then we do have to think about the signs, right? So for those signs, the top one is positive, the bottom one is negative. That's what we want, because the only way you can add to 0 is if it's a positive plus a negative, but it's the same basic number otherwise. And so I want them both to be 6's, but 1 plus, 1 minus. So the other way you could have done this then is multiply the bottom equation by a positive 6. And if you did that, this is what that work would look like. You'll notice that in this case, that ends up giving me what x equals first. And then I plug that in to find y. However, we get the same answer. It's the same amount of work. Everything still matches up. So it doesn't actually matter which one you do. So my suggestion is that whenever you see one of these problems, start by looking at the numbers involved. Start by seeing if you can just add straight away. And then if you can't, look to see which one is going to be easiest to make add to 0 from there. Okay, so we've seen that type, but then some of them are even harder than that. Some of them look like these. Go ahead and write this one down, then we'll walk through it together. And so in order to do this one, we first look to see, will anything eliminate right away? Can I just add them right now? No, because these don't add to 0. These don't add to 0. So I need to make it so that one of those does add to 0. And right now, in order to multiply just like one of the equations by something and make that happen, I'd end up getting into fractions or decimals. This would be kind of ugly. So I don't want to get into fractions and decimals. It leads to errors. So you can actually multiply both equations by different numbers, and that's okay. And yeah, it's kind of like finding a common denominator. You're looking to see what can I turn both of these into. And so let's say that I wanted to make the x's cancel. If I want to make the x's cancel out here, what could I multiply the equations by?
-5.
One option, yes. I could do -5 and 3. But yeah, that gives me 15, and one of them's positive, one of them's negative. But there's nothing magical about the top one being negative. If we wanted to, we could multiply the top one by 5 and the bottom one by -3. That would also be fine. So both of those situations would make the x's cancel out. Okay, but you might be looking at it and thinking, well, I think it's easier to make the y's cancel out because one of them's already positive and the other one already negative. So you might think that's easier. If that's the route you're going with, what would you multiply them by? Well, I'm wanting to make both of these numbers turn out to be the same number. The easiest way to do that is you could just multiply them by each other. So I could multiply the top one by 4 and the bottom one by 6. And so I can just multiply them by each other to get that to be the same. As a side note, if I didn't want to make it by 4 and 6, I could actually make them both in like 12. So I can multiply by like a 2 and a 3. That would also work. So you notice there's lots of different ways to make this happen. Basically, pick one and go with it.